The Maine Association of Site Evaluators, commonly referred to as MASE, is an organization of licensed professionals that design septic systems. Hello, my name is Tim Wade, and I am the current president of MASE. As site evaluators, we specialize in evaluating and identifying suitable sites for subsurface wastewater disposal systems, or septic systems. Upon identifying a suitable location, we develop a design plan that will address the needs of the home or business based on the standards outlined in Maine's Subsurface Wastewater Code. Once our design is complete and permitted, a reputable contractor has been selected, the installation process may begin. A listed objective in the second article of our Constitution is to advance public welfare through furtherance of public awareness and education. The following video demonstration is intended to offer insight to homeowners and other professionals interested in learning more about the permitting, construction, and inspection of septic systems in Maine through this live-action installation and accompanying narrative. This presentation is meant as an educational aid. As in real life, weather and other factors cause adjustments, and you may note minor discrepancies or variances in the film. Always consult the site evaluator, local plumbing inspector, product manufacturer, and/or Maine's Subsurface Wastewater Code for guidance to the rules and specifications. MASE is proud to have teamed up with Midcoast Habitat for Humanity, LaBranch Land Surveys, Dave Studer, American Concrete Industries, Construction Consultants Incorporated, Eagle Rental, Eljen Corporation, E.J. Prescott, George Hall & Sons Excavation, Stephen McGee Construction, and TJ's Excavation to design and install a new septic system for the Habitat for Humanity home built in Warren, Maine in the fall of 2017. Myself and several other MASE members were on site for the installation. We are here today at the Habitat for Humanity home in Warren, where MASE has been working to design and install a septic system for a 4-bedroom residential house being built. I am here right now with Dave Studer. Hi, Dave.
Hi, Tim.
Dave is a fellow MASE board member and the licensed site evaluator that did the design for the house that we're on today. Dave, can you tell us a little bit about the soils that you found on site?
Sure. Well, first of all, the reason we dig holes is so that we can see where the water is starting to go sideways instead of down. The other reason is we want to know how the soil is for accepting water. If you look at the hole, about 12 inches down, the roots stopped and there was a firm place, and you could start to see where the water would probably go sideways rather than down. And I called it, the top part of it I called the sandy loam, and right about 12 inches you got about a silt loam. And then I dug down to about 30 inches to make sure there wasn't anything else in there like ledge or something that we didn't know about. A silt loam doesn't accept water very well, so you have to make it larger. In this case, you need 5 square feet for every gallon you get rid of. So that's in contrast to something that's very sandy, where you might only need, say, 3 or 3.5 or somewhere in that neighborhood.
And how did you determine the elevation of the system?
Well, we had an elevation reference point, which is a nail over in the road that we use as a 0, and then we measure down. I usually use a pop level. Some people use transits and so on. And if you measure where the surface is, and then I dug a second hole over there just to confirm that it was the same 12 inches. And then with all the reference elevations, then you can start to draw your plan.
Dave, so you mentioned you'd be able to use the Elgens to get a smaller size system. Comparatively, we're all used to stone beds. How much smaller is this system because you're using an Eljen in-drain system?
Typically, they're somewhere around 1/4 of the size,
wow,
approximately.
Wow.
So a stone bed would be 20 by 70, 75. This is only 19 by 30.
Wow, so that's quite a reduction.
It is.
Excellent. All right, well, Dave, we're going to get started on installation. You're going to be here to help us through it, so let's get going.
The site evaluator should provide the applicant with several copies of the design. A minimum of 3 copies are taken to the local plumbing inspector, or LPI, for review and permitting. It is important for the applicant to sign the first page in the designated place. The LPI will return a signed copy to the applicant. This becomes the permit. The permit will need to be present at the 2 mandatory installation inspections by the LPI. The design must be a minimum of 3 pages. The first page will be the application page. This page includes information about the applicant, the property, the intended use of the property, and the system design criteria and sizing. The second page of the design shows a location plan, a plot plan of the lot or the area of the system, and test pit soil logs. There may be an additional page of soil logs if more than 2 pits are recorded. The final page or pages of the design shows the cross-section and plan view of the system. The pages provide scale drawings of the system as well as call-out specifications and notes for construction. The design elevations are shown on these pages. Ties to the system corners may be found on the plot plan or the system plan view. The site evaluator's contact information is located on the bottom of page 1. Any questions regarding the design should be referred to the site evaluator first. The first step in any excavation project in Maine is to call DigSafe to have underground utilities marked. You should also check oktodig.com to have any non-member utilities marked as well. DigSafe and Maine Public Utilities Commission can help answer any specific DigSafe law questions, but it is important to mark out the site and call it in 3 full business days before you plan to start digging. It's smart and it's the law. During any excavation project, erosion control must be considered. Silt fence is a protective measure that can be employed to contain the work area, especially if the site may remain open for some time. Our team lays out the fencing so the staked side is facing away from the work site. The fence must be keyed into the soil approximately 6 inches to prevent breakthrough. There are many other forms of erosion control that can be used, and you should always follow the manufacturer's recommendations or the Department of Environmental Protection's Erosion Control Best Management Practices Manual for installation. If the design calls for an erosion control measure, it must be installed. Any site disturbance in the shoreland zone requires a contractor certified by the Department of Environmental Protection. Once erosion control measures have been installed, the grubbing can commence and the topsoil is removed for the system installation. As the excavator, provided by Peter Fennelson of Eagle Rental, positions to begin the sod removal, Dylan Ross of E.J. Prescott arrives with a delivery of donated piping and other materials for the job. The first delivery of septic sand arrives from George Hall & Sons. Septic sand is a clean, coarse sand that will be used to construct the transitional horizon, build the system up to the bottom elevation, and construct the fill extensions. It is important to lay out the system, including all fill extension extents, prior to grubbing. It is good practice to set a couple of offset stakes to the corners to easily re-establish them after removing the sod. This is also a good time to check elevations and devise an excavation plan. System elevations are designed based on a local elevation reference point, or ERP. The ERP is often a nail in a tree, a drill hole in a rock, or some other permanent and fixed point. The reference elevation is always specified as 0 inches, and system elevations are displayed in negative numbers as they are located below the ERP. For the Warren house, Dave found a survey nail in the hut top to be the most convenient place to locate the ERP. In Warren, Maine, in early October, rain is a common occurrence. It had been showering through the morning, but the rain was becoming more steady as we prepared to start removing sod. Because of the poorly drained soils, Tim decided to hold off on opening the system footprint. If the soils under the system become smeared, the system would have a high probability of early failure. Instead, the team moved to preparing the septic tank excavation for an early morning tank delivery, leaving the grubbing for better weather tomorrow. The septic tank size will be defined on page 1 of the design. A 1,000-gallon tank is most common for residential applications and is adequate for up to 4 bedrooms. While there are other tank materials, concrete is the most commonly used tank. The 1,000-gallon septic tank is approximately 6 feet wide and 8 feet long. The tank is about 5.5 feet tall, but elevations should be measured from the inlet and outlet holes. The plot plan or system plan may show a recommended location for the tank, but the tank location may be moved so long as all setbacks are met. The tank must be 8 feet from the building in most cases. It is good practice to overdig the tank by 6 inches to allow for the placement of stone as a footing. The stone provides a solid base that is well drained and is easily raked and shimmed and requires little compacting. Will, at American Concrete, has his delivery truck out early in the morning, and the tank is being set as the sun is coming up. Most tank suppliers have the ability to set the tank for you. It is important to make sure your hole is large enough and at the right elevation before delivery to avoid additional fees for on-site time. The tank is lowered into the hole as Tim and MASE Vice President Russell Martin check for position and alignment and the proper installation of the plug. The tank must be set level. A tank normally is constructed with a 3-inch elevation drop from the inlet to the outlet. It is best to check for level at the seam between the cover and the tank, as there may be imperfections on the surface of the cover. There must be a minimum of 1/4 inch per foot pitch in the building sewer pipe connecting the internal plumbing to the tank. It is a good idea to double check this before unhooking and sending the delivery truck on its way. Depending on the system elevation and the tank elevation based on the building sewer elevation, the system may require a pump station to lift the effluent to the drain field. In this case, the tank outlet was high enough to allow for gravity flow from the tank to the field. With the tank set and the sun out, the system footprint is finally being opened up. It is important to limit any traffic over the open soil to tracked machines and to try to keep that to a minimum and avoid steering that may cause the soil to smear. Clean spoils may be piled up to reuse as topsoil. We recommend the use of a quality screened loam over the system and components. The fill extensions and other disturbed areas are a good spot for the stripped soil. When all the sod has been removed and any roots, large rocks, or other organic or foreign materials have been removed from the entire footprint, septic sand is blended into the top several inches of soil to create a transitional horizon. This interface prevents smearing or compaction of the native soils and promotes drainage under the field. A homogeneous mixture of soil and sand is desired. With the system bottom prepared, the LPI is notified that we are ready for the first inspection. Installers voluntarily certified by the Maine Division of Environmental Health may request the first inspection to be waived. The LPI has the sole discretion to waive the inspection and may still require it. Warren, like many communities, contracts with other municipalities to share their LPI, Scott Bickford. Scott arrived to check the system ties and the preparation of the bottom. With the LPI's approval, the team begins to build up to the bottom of the system elevation. The clean, sharp sand is used to build the area under the system up to the bottom design elevation. This sand should be placed and gently compacted. A quality sand will still drain well when compacted, but left loose will settle over time and cause premature failure. As the system nears the bottom elevation, Wayne of Construction Consultants of Maine and Meg with Eljen Corporation arrive with the Eljen GSF units. These units are used in lieu of the familiar stone and pipe system and allow a more compact layout, as Dave spoke about. The manufacturer requires a special sand to be used 6 inches below and 9 inches around the units. On cue, Seth McGee of Steve McGee Construction delivers the required ASTM C33 sand. The team spreads the first 6 inches of sand beneath the disposal field in preparation for the installation of the Eljen GSF units. The sand is raked to grade, allowing the units to be installed level. In some designs, rows may be stepped with a natural slope to minimize septic sand fill below the disposal field. This field is being installed level across all rows.
Hi, my name is Meg Thompson. I work with Eljen Corporation out of East Hartford, Connecticut. So these are the Eljen transverse units. They're 4 foot wide, 3 foot long. They just butt up against each other at their ends. The white stripe shows you which way is on top. The units themselves are made out of what we call a cuspated core in a geotextile fabric. The cuspated core is these waffle ice cube trays that space the geotextile fabric out. That helps to provide oxygen throughout the system. With this product, what we're doing is biomap management. So we're keeping that activity on the product itself instead of on the soil interface. What that does is preserves the soil's long-term acceptance rate. Eljen systems are required to use what we call specified sand. It's a washed concrete sand meeting the ASTM C33 spec. And what we're really looking for is that it has fines less than 10% passing the number 100 sieve and 5% passing the number 200 sieve. We consider the sand part of the system, and what it does is it helps the effluent have enough stay time so it becomes treated, but it doesn't create a saturated condition, so there shouldn't be any ponding, and it's going to help to disperse that effluent to the ground.
With the Eljen units in place, the distribution pipe is laid across each row. The pipe is 4-inch perforated Schedule 20 with the holes facing downward at approximately the 4 o'clock and 8 o'clock positions. The pipe is held in place with wickets provided by Eljen. Each row is connected by a manifold on the far end and the distribution box at the inlet side of the field. All distribution pipe must be laid level. With the distribution pipe in place, the units and piping are covered with the supplied geotextile fabric and additional sand. With the transverse units, additional fabric is required in order to cover the entire width of the units. C33 sand must be used to fill to the top of the units. Septic sand may be used to cover the system. Early the next morning, the LPI is here to inspect the system. Because the weather on day 1 delayed us, the final connections to the tank have not been made, so Scott agrees to come back, but checks the system construction and elevations and checks out the tank on this stop. With hours left in our schedule, and a lot of work in front of us, the reinforcements arrive to plumb the tank to the system. MASE board member Brianna Dennis locates the distribution box and cuts the holes that will be used to feed each row of the system. The plastic fillers are marked with different pipe diameters. We are using a 4-inch pipe, so Brianna is removing the 4-inch ring with a sharp knife. It is crucial that this box is placed level on well-compacted soil and is insulated to prevent freezing or settling. We use 2-inch styrofoam underneath and on top of the D-box for this purpose. With the box in place and level, Russ and Brianna begin to connect each row to the D-box using solid 4-inch Schedule 20 pipe. Finally, the tank effluent pipe is connected to the D-box. This pipe is 4-inch SDR35 or Schedule 40 PVC solid pipe laid with a minimum of 1/8 inch per foot pitch. Joints are glued or gasketed. When using gasketed pipe, cut ends must be beveled to properly seat without damaging the gasket. Pipe penetrations in the tank and D-box are sealed by the factory gaskets. Other methods, such as spray foam, may help with any imperfect cuts or add an extra layer of protection. Like the disposal field, proper compaction under the pipe is critical. Poor compaction under or near the piping may cause settling, leading to premature failure. As Tim begins to cover the system with an additional 4 inches of sand, Brianna and the rest of the team make the final connection from the stub left by the internal plumber to the tank. This piping must be 4-inch Schedule 40 PVC solid pipe and is laid at a minimum pitch of 1/4 inch per foot. Couplings or joints must be glued. A flexible rubber coupling may be used in lieu of a glued plastic coupling, but extra care should be used to support the flexible coupling.
What we have here is a device called an effluent filter that goes in the septic tank in place of the normal outlet baffle. And essentially what you have is a screen. It's an extra layer of protection for anything that might make it through the tank, hair or grease or whatever. So since it's a screen, obviously it has to be cleaned occasionally. Typically what one would do is simply wash it off back into the tank. Now this particular effluent filter is one that uses a ball at the bottom. So when you've pulled this out, that ball will float back up and essentially plug the outlet.
The disposal field has been covered with an additional 4 inches of septic sand. Now 4 inches of topsoil is placed to establish grass cover. A load of screened loam is delivered by TJ Benner of TJ's Excavation as the team finishes compacting and begins cleanup. The loam is spread and raked to direct surface water away from the system. Seed and hay are spread to encourage grass growth and minimize erosion. The LPI returned for an informal final check of the plumbing. After the inspection, remaining system components were covered. As the sun set on the 3rd day, the installation was complete.
The Maine Association of Site Evaluators was pleased to be able to help provide the Midcoast Habitat for Humanity a designed and installed system for less than 1/4 of the estimated cost. We would like to again acknowledge and thank all the vendors that helped to make this possible. The Warren system, like any other, won't last forever, but with proper use and maintenance should function for the family for the next 2 decades or so. In order to properly maintain your system, follow a few easy steps. Never flush fats, oils, or grease. Always avoid flushing medications, rags, wipes, diapers, feminine products, or other disposable items. Avoid installing a garbage disposal and make provisions with your designer if you intend to install one. When possible, avoid flushing water treatment systems into the septic system. Avoid the use of enzyme treatments. Always have your tank pumped every 3 to 5 years. At the first sign of trouble, call a professional to look at the system. Sometimes a simple repair can save you thousands of dollars in replacement costs. We hope you have found this video beneficial. Please direct any questions to info@mainse.com, where our association can provide feedback. Check out our website at www.mainse.com for more information.